when we're asked to find the distance between 2 points, we're really thinking about a graph. And I think it helps to have a picture that we can use to just roughly see where the points are located. It doesn't need to be something where you're scaling it, just looking to see where they're roughly located. So I know if I'm looking at these coordinates, the first coordinate is the x coordinate, the second one is the y. So if I go -7, here's my x-axis. If I'm going -7, it means I'm moving to the left, and then I'm going +4, so up 4. So again, this is just a really rough placement of where that point could go. Then for this point, I'm going to the right 2 and down -10. And it just gives me an idea that this point here, this first one, is further to the left and up. This one's further to the right and down. And so what I'm trying to find is this distance. I want to know how long that line is that I just drew. What's that distance? Well, to find that distance, because we're working on a graph, the way that we would measure is we would use the Pythagorean theorem as a tool. Because the coordinates, the x coordinates run right and left, and the y coordinates run up and down, we can use the coordinates to find these legs. I made kind of an imaginary right triangle here, because what I really care about is this distance. But if I make this imaginary right triangle here, and I find these legs, I can use the Pythagorean theorem to get that distance. So the work that I do first is just for finding the legs. So here, if I'm finding this horizontal leg, I'm going to use the x coordinates. This x coordinate is 2. It's all the way to the right 2. This x coordinate is -7. So I'm going to take 2 and subtract -7. We know that subtracting a negative is the same as adding. And so because we took the larger number and subtracted the smaller number, we end up with a positive number, 9. Now I'm going to work to find that vertical leg. And because it runs up and down, and the y-axis runs up and down, I'm going to use these y coordinates, 4 and -10. Again, I'm going to take the larger one, 4, and subtract -10. So 4 minus -10. Subtracting a negative will be the same as adding, so 4 minus -10, I'll get 14 there. These are the legs. These are the legs of the right triangle. So I think it would help to even put these on your picture. This is 9 here. This is 14. That'll help you to remember that you're not done yet. What you were supposed to find is this distance. And so now we can use the Pythagorean theorem. Because I'm finding the hypotenuse, I'm going to write out the Pythagorean theorem over here. The leg squared plus the leg squared equals hypotenuse squared. And I have the two legs, 9 and 14. So I'm going to find these values here. 9 squared is 81. 14 squared is 196. I'm just typing these into the calculator. And because I'm finding the hypotenuse, and I know both of these legs, I'm just going to add this together, and I get 277. Okay. This is the length of the hypotenuse squared, so it's really the area of that square that's coming off the hypotenuse. And so now I'm going to square root that. So the hypotenuse, to undo squaring, I want to square root. And when I type that into the calculator, I get 16.64 units. That is the hypotenuse. That's this distance between these 2 points here.